Hello friend, today in this video lecture we are going to learn the numerical integration. Given set of data point x0, y0, x1, y1 up to the term xn and yn of a function y is equal to f of x is not known explicitly. It is required to compute the value of definite integral I is equal to integration a to b y dx. We derive the general formula for numerical analysis for numerical integration using Newton forward formula. Let the interval AB be divided into n equal subinterval such that a is equal to x0 up to xn minus 1 xn is equal to b less than x2 less than x1 x2 up to the term xn, and given integral becomes I is equal to integral x0 to xn y dx, approximately by Newton forward formula, Newton forward difference formula. We obtain I is equal to integral x0 to x1 y0 plus del y p into del y0 plus p into p minus 1 upon 2 factorial del square y0 plus p into p minus 1 p minus 2 upon 3 factorial into del cube y0 into del x. Put here x is equal to x0 plus ph and differentiate this, then del x is equal to p dh, and put the value of del x in above integral, then I is equal to h into integration 0 to n y0 plus del y0 del y0 p plus p into p minus 1 upon 2 factorial del square y 0 up to the term, last term, then del x is equal to del p. After integrating, then we get h into first integration of y0 is constant and integration of del p is equal to p. P is limit 0 to n plus del y0 p into del p, then integration of this p square by 2 0 to n plus 1 by 2 into p cube by 3 minus p square by 2 del square y0 plus 1 by 6 into p to the power 4 by 4 minus 3 into p cube upon 3 plus 2p square upon 2 0 to n del 0 cube y0 and so on. Means first calculate this bracket p into p minus 1, then calculate the next bracket p into p minus 1 into p minus 2, and then integrate this, we get this value. Then we get I is equal to h into y0 n plus n square by 2, putting the upper limit, lower limit is 0, plus 1 by 2 n cube by 3 minus n square by 2 del 2 y0 plus 1 by 6 into n raised to the power 4 upon 4 minus n cube minus plus n square del cube y0. Then we get h into y0 n plus n square by 2 del y0 plus n by 2 into bracket 2n square minus 3n del 2 y0 plus n square upon 24 into bracket n square minus 4n square plus 4 del cube y0. Then write I is equal to n common, then nh into bracket y0 plus n by 2 del y0 plus n into bracket 2n minus 3 upon 12 del 2 y0 plus n into n minus 2 whole square upon 24 del cube y0 up to the n term. This is equation 1. Then we see the second topic, trapezoidal rule. Put n is equal to 1 in equation 1 all difference higher than the first will be 0, and obtain integral x0 to x1 y dx is equal to h into y0 plus 1 by 2 del y0, because second differentiation is 0, this term is 0. Put n is equal to 1 in this equation, then we get this equation. Then h is equal to y0 plus 1 by 2 and del y0 is equal to y1 minus y0. And then after calculating h by 2 into 2y0 plus y1 minus y0, and then we get h by 2 into y0 plus y1. Similarly, for interval x1 x2 is integration x1 to x2 y dx is equal to h by 2 into y1 plus y2. And for last interval xn minus 1 xn, we have integration xn minus 1 to xn y dx is equal to h by 2 into yn minus 1 plus yn. And combining all these expression, we obtain I is equal to integral x0 to xn y dx is equal to h by 2 into y0 plus 2 into bracket y1 plus y2 plus y3 up to the term yn minus 1 plus yn. Here first and last term is 1 and other term are twice, and which is known as trapezoidal rule, which is the trapezoidal rule. Then next is Simpson 1 by 3 rules, or Simpson, only Simpson or Simpson rule. This rule is obtained by putting n is equal to 2 in equation 1 and all difference higher than second will becomes 0, and we obtain integral x0 to x2 y dx is equal to 2h into y0 plus 2 by 2 del y0 plus 2 into 4 minus 3 upon 12 del square y0 is equal to 2h into y0 plus y1 minus y0 plus 1 by 6 into del y1 minus del y0 is equal to 2h into bracket y1 plus 1 by 6 into y0 minus 2y1 plus y2 bracket complete. Then LCM of this term is equal to 2h into bracket 6y1 plus y0 minus 2y1 plus y2 upon 6, then 1 by 3 h into bracket 6y1 plus y0 minus 2y1 plus y2 after calculating h by 3 into bracket y0 plus 4y1 plus y2. This is the value of integral x0 to x2 y dx. Similarly, integral x2 to x4 y dx is equal to h by 3 y2 plus 4 y3 plus y4, and up to the last term, n term, we can write integral x n minus 2 to x n y dx is equal to h by 3 y n minus 2 plus 4 y n minus 1 plus y n, and combining all term, these all integral, we obtain integral x0 to xn y dx is equal to h by 3 into bracket y0 plus 4 into the term y1 plus y2 up to the term yn minus 1 plus 2 into the term y2 y4 y1 y3 plus y5 means all odd term, and second bracket 2 into y2 y4 up to the term yn minus 2 plus yn, and which is known as Simpson rule. Then third rule is Simpson 3/8 rule. In this rule, put n is equal to 3 in equation 1, and all difference higher than third term will become 0 and we obtain integral x0 to x3 y dx is equal to 3h into y0 plus 3 by 2 del y0 plus 3 into 6 minus 3 upon 12 del 2 square y0 plus 3 into 3 minus 2 whole square upon 24 del cube y0. Then put the value of all this term and we find that integral x0 to x3 y dx is equal to 3 by 8 h into bracket y0 plus 3y1 plus 3y2 plus y3. And similarly, integral x3 to x6 y dx is equal to 3 by 8 h into bracket y3 plus 3y4 plus 3y5 plus y6, and up to the end term integral xn minus 3 to xn y dx is equal to 3 by 8 h into yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn, and combining these all terms we get the last integral, and that is integral x0 to xn y dx is equal to 3 by 8 h into bracket y0 plus 3 into y1 plus y2 up to the term yn minus n minus 1 plus 2 into bracket y3 plus y6 up to the term yn minus 3 plus yn. This is the formula for, means here first and last term is once and y3, y6, y9, yn minus 3 are twice and other term are thrice. This is the formula for Simpson 3 by 8 rule, means trapezoidal rule put n is equal to 1 in equation 1, and in Simpson 1 by 3 rule put n is equal to 2 in equation 1, and Simpson 3 by 8 rule put n is equal to 3 in equation 1, and then we get the formula for these three methods. Thank you.